projectile motion. That's when you throw something or
launch it.
When you project something.
Physics people will love this kind of stuff.
Right. So when you throw an object, its path can be modeled with a parabola because, especially if you throw it up, like it's going to go up and then come back down.
Mm-hmm.
The general formula for this using parametric equations is this set of equations right here. And then in that, V sub O, that's the initial velocity.
V naught,
you could say. Theta is the initial angle that you're projecting at, and H is the initial height. So we've got an example here where the first thing we want to do is write a set of parametric equations that models the motion of a kicked football.
Wow. That's, are we talking the punter for the Edmond Memorial football team is in old school football, as in what the world plays, or is that American football?
I think it's talking about the Edmond Memorial football team.
So the soccer football team or the
No,
football,
the football team.
Football team.
Isn't it the football team? We're trying to punt.
The goalie punts and okay.
All right, so X equals, in the paragraph here, we've got information. Our initial velocity, our V naught, is 85. Our initial height is H. Our theta is 35, so we just got to fill it in.
That doesn't sound too tough.
No, not tough at all. Keep in mind
Now,
this is in degrees.
I was just getting ready to say, how do I know what mode for my calculator to be in?
Well, all you got to do is look
Call
at the degree.
Ghostbusters.
So these equations actually come from a very physicsy thing, like breaking up the x part of the motion and the y part of the motion. That's why cosine is with x, which if you remember anything from our trig stuff this year, hopefully you remember that x and cosine go together, sine and y go together. And then in the y equation, we also have to add in the fact that gravity is working against the ball. And that's where this negative 16t squared is coming from.
Yeah, hold it down. Keeps it from going into low Earth orbit.
Yeah, so this right here is our set of parametric equations that models the motion of our football. That's part A. We're going to look at the rest of this stuff on the next slide here. Oops.
Pick it. There you go.
All right, so I just copied those over so I can refer to them. We're going to sketch the graph. So go into your calculator in parametric mode. Make sure you're also in degree mode, and put in that set of equations.
Enjoy a starburst. Yeah, sorry. I had to clear off the old graphs. All right, so here we go. 85 cosine 35t. So cosine 35 times t. And negative 16 t.
Did you need a degree symbol?
T squared. No, I think I have it set for degrees.
Okay.
We'll see in 1 minute, won't we?
Mm-hmm.
But I thought I picked degrees. Plus 85 times sine 35 times t plus 2. Bam. And perhaps I picked incorrectly here. Let me just double check these.
That's a terrible thing to have happen.
That was horrible.
That
1 minute.
was the worst.
1 minute, please. It says I'm in degree mode here, so I don't know what the heck. $85 times cosine 35t. 16t squared plus 85 times sine 35t. Let me just this is weird. Well, that made a difference. So apparently I needed to put the degree symbol in. You were right, of course, like always. Now, I need a good window here, so...
Well, we only need positive x values.
Right.
So, like, from 0 to, I don't know, like, 250? You wanna
250?
try 250?
All right, we'll try 250. And the same for the y-axis.
Yeah. And that'll just give us an idea if we're even close. He picked a y of 100.
100's a little big, so maybe 75 or 50?
Okay, change it.
Yep. 250 is good on x, so I'm going to try 50 for y. Oh, it's perfect. Well, after all that work, I need a candy. After this lesson, I need a candy.
All right, so we've got this parabola, and ish. Okay, it doesn't have to be super accurate, but we know that our x values need to be like a good window is between 0 and 250.
Mm-hmm.
Our y values
0 and 50.
from 0 to 50. His t values were automatically set to go from 0 to 2 pi, and that seemed to work out fine. And his t step was like
Let me check on that.
Something.
Yeah, 0.13, yep.
So now that we've got this sketch, it will help us think about some things. For example, when we are asked what is the maximum height reached by the football, they're asking us to find this point. Now, I don't know about on the Inspire, but on the 84s, it won't let you calculate that point.
You know what? I'll just check real quick.
Okay, so the idea here is when is our y value going to be the biggest? So let's look at our equation for y. And let's think about it by itself. If we just have this equation for y, what kind of equation is this? Well, that itself is a parabola. And so we could go back into our rectangular mode and graph this with x's instead of t's and calculate the max of that parabola.
Right.
And that will tell us what this maximum height is.
We could take a derivative and set it equal to 0.
We don't know how to do that. We're not in calculus.
All right.
So why don't you...
I have an idea.
Yeah?
If this is a uniform parabola, couldn't we just take the x coordinates and look at the halfway point? Like maybe find where x equals 0 and go halfsies? Just tossing it out there.
I guess we could.
I can graph the other one too.
Okay.
So I'm graphing us negative 16t squared plus 85 sin 35 degrees. Not forgetting that guy this time.
Yeah, good call.
X plus 2.
All right, so he's putting him in with x's here instead of t's so that we can look at that kind of parabola. Now that parabola
changed my window now.
Yeah,
gotta
now
change my window
because now that's going to be a little parabola tiny in the corner.
So 50 is still too big, but we can see.
But we can find the maximum.
But we can find the maximum.
So you go to second calculate and go to maximum.
Yep.
Or on your Inspire, you go to analyze
graph and max.
Pick left bound, right bound.
Lefty, righty. Okay, here's what I get. I get the coordinate of 1.524, 39.14.
Okay, so let's think about what that's telling us. That's telling us what the maximum for this is, where our x's were really t's,
right,
and our y was really y. And so that means the maximum height reached by the football will be 39.14 feet. We want the y value. What's the biggest our y values can get to.
Right.
And if it asked us what time that happened, it would be at 1.524.
Right.
But it doesn't ask us
Doesn't
that.
ask.
So now it asks when and where will the football hit the ground. Now, you mentioned the whole, if this is a uniform parabola, then we should be able to split this in half. And so we actually could use that, because if at halfway it took 1.524 seconds, then if we multiply that by 2, then that should give us how long it takes before it hits the ground.
This is 3.048.
It's what,
3.048.
48 seconds. Okay, so that's how long it takes. And then we can plug that into our x equation to figure out what this, we're asking, where is this point right here? What x value is that at?
Right.
So we'd plug it into the x equation. I didn't think of that when I originally worked this, and so the way I actually did it was I I set this equation equal to 0, which
You
I
could
think
do
is
that
what
too.
you were, you said something about maybe, I don't know. Because whenever you were talking about finding where it hits and doing
Right.
half or something like
Right,
that.
right.
What am I doing? 3.048.
Oh, 85 times cosine degrees times 212.226.
And that makes sense considering what our window was. That seems
Right.
about right. So that's feet. And that's it. So for problems like these can be really difficult, but you got to break it down and think, okay, is it asking me where the x value
Right.
is? Is it asking me where the y value is? What is it a maximum? How do I find a maximum? You know, things like
Right,
that.
stuff like that.
All stuff we've done before.
Indeed.